Hello world, this is YernarProjects.com. We talk about project management planning methods. Today we will find out what is critical path, why and how to use this method. Critical path method shows the time necessary to complete an activity, activity dependencies, milestones, deliverables and how each activity is connected to a former and subsequent activity. This critical path method depicts the connection between activities and the length of each activity. A series of activities is called a path, and the longest path in the diagram is a critical path. The critical path is the path that justifies the final project timeline. In other words, critical path is longest sequence of activities in a project plan, which must be completed on time for the project to complete on due date. An activity on the critical path cannot be started until its predecessor activity is complete. If it is delayed for a day, the entire project will be delayed for a day, unless the activity following the delayed activity is completed a day earlier. Critical path method is a mathematically based algorithm for scheduling a set of project activities. The essential technique for using critical path method is to construct a model of the project that includes a list of all activities required to complete the project, the dependencies between the activities, and the estimate of time that each activity will take to completion. Using these values, critical path method usually calculates the longest path of planned activities to the end of the project, and the earliest and latest points that each activity can start and finish without making the project longer. This process determines which activities are critical and which can be delayed without making the project longer. The critical path consists of the longest sequence of activities from project start to end that should be started and completed exactly as scheduled to ensure the project is completed by a certain date in the future. The activities on the critical path must be very closely managed. If jobs on the critical path slip, immediately action should be taken to get the project back on schedule. Otherwise, completion of the whole project will slip. Imagine that you have a project that will take 300 days to complete. If the first activity on the critical path is 1 day late, the project will take 301 days to complete, unless another activity on the critical path can be completed 1 day earlier. So, the critical path is simply all the tasks that determine the end date in your project schedule. Traditional critical path derived schedules are based only on logical dependencies. However, a project can have resource limitations, which also should be taken into consideration. These limitations will create more dependencies. These dependencies are often called resource constraints. So, if you work on a team, your project work can be split between the project members. However, if you are the only person responsible for the project, you have a resource constraint. These are key steps in the critical path method. Specify each activity. Establish dependencies. Draw the network diagram. Estimate activity completion time. Identify the critical path. And make constant update. As you are going through the critical path method, you may find that you want to intentionally shorten the duration of your project or that you need to compress your project schedule in order to meet the deadline. There are two ways to do this: fast tracking or crashing. In fast tracking, you look at the critical path and decide which activities can be done parallel to each other to move the project along faster. You only need to review the activities on the critical path because all the other activities have flowed. Crash duration or crashing refers to the shortest possible time for which an activity can be scheduled. This happens by adding more resources to completing that certain activity. However, crashing the critical path results in lower quality of work because the goal in crash duration is speed. As you manage your project, you may also run into resource constraint issues that could change the critical path. If you try to schedule certain activities at the same time, you may find that you need more people than are available. As a result, those activities will need to be rescheduled. Resource leveling is a process of resolving these conflicts. With resource leveling, you can resolve conflicts over allocating resources. A resource-leveled schedule may include delays due from resource bottlenecks. Resource leveling may also result in a previously shorter path becoming the longest or most resource-critical path. This happens when the tasks on the critical path are affected by resource constraints. The forward pass, backward pass technique is another way to find the critical path. It is best used when you have multiple branches or multiple entry points for an activity. You may also need to use the forward pass, backward pass technique if you are asked to identify the early start or finish times, or latest start or finish times for an activity, or to find the slack or float for each activity. Before you start using forward pass, backward pass technique, here are some terms that you first need to understand. Earliest start time. The earliest time an activity can start once the previous dependent activities are completed. Earliest finish time. Earliest start time for the activity plus the time required to complete the activity. Latest finish time. The latest time an activity can be completed without delaying the entire project. Latest start time. The latest finish time minus the time required to complete the activity. The first is a forward pass formula for you to use as you move from beginning to the end in your project network diagram. This formula will find the earliest start time and the earliest finish time for each activity. To start the forward pass, make the ES of the first task 0. For all other tasks, the ES is the same as its immediate predecessor's EF. Use this formula on screen to calculate EF. The second formula is for backward pass, when you are moving from the last activity to the first activity. This formula will find the latest start time, LS, and latest finish time, LF, for each activity. To start the backward pass, make the last activity's LF the same as it is EF. For all other tasks, the LF is the same as its immediate predecessor's LS. Use this formula on screen to calculate LS. Now that you have calculated ES and LS for each activity, you can find the float. The slack time, also known as float time, for an activity is the time between the earliest and latest start time. Critical activities, activities on the critical path, will always have 0 slack. There are two formulas to calculate slack based on the values you identified in the forward pass, backward pass technique.